believe it or not, there are physicists who say that we cannot rule out time travel. To actually go backwards in time, you have to use a higher theory, Einstein's general theory of relativity of 1915, in which case space and time is a fabric that perhaps you can rip if you have unimaginable sources of energy.
Mathematically, we can devise methods or structures or ways to explain the possibility of time travel. But the actual reality of that mathematics is very questionable and perhaps even fantastic.
The key ingredient for a time machine would be either a black hole of some sort or negative matter and negative energy. Many people have speculated as to what happens when you go through a black hole. The theory says that it's not going to be very pleasant at all. If the black hole is small, then as you approach the black hole, you will be spaghettified. That is, the top and bottom of your body will be stretched like a spaghetti. Not only will you be ripped apart, but the atoms of your body will also be spaghettified, and they will be ripped apart as well.
There is no way that we know of, or that we can even think of, that we could create an object that might, say, hold a human being, or anything larger than a subatomic particle, actually go into a black hole, surviving what's going on in the boundaries, and then what's inside, and then coming out some other location, some other time. So, practically speaking, it absolutely is not possible.
One version of a time machine uses what is called a wormhole. A wormhole is a subway trip through space and time. It was Einstein himself in 1935 that first proposed the possibility of wormholes, and we find that Einstein's equations are littered with wormholes. Wormholes to the future, wormholes to the past.
The idea of a wormhole is sort of a more generalized version of the black hole time travel idea. Black holes, because we know they are scientific reality, have been proposed as the most likely type of wormhole. But the idea of a wormhole is very simply that you come into that hole from within our universe, temporarily exit the universe, exit our space-time continuum, and return again to our space-time continuum at some other space location and some other time location.
Now, Isaac Newton believed that time was like an arrow. Once you fired it, it went in one direction, so that 1 second on the Earth was 1 second on the Moon, was 1 second on Jupiter. Time beat uniformly throughout the entire universe. Then along comes Einstein, who says, not so fast, not so fast. Time is like a river, a meandering river that meanders around stars and galaxies, speeds up and slows down. Now, the new wrinkle in all this is that we physicists believe that the river of time may have whirlpools. The river of time may fork into two separate rivers.
Time is a dimension, but it's so unusual in the sense that we can only move forward in it as long as we're in our universe, that we're trying to always find ways, at least mathematically in our minds, in our imaginations, ways to travel backwards in time. By doing that, what we're literally doing is affecting a very important part of our physical universe called causality. If we want to try to travel backwards in time, most scientists agree that there has to be a way to prevent causality from being violated. Otherwise, all of our laws of physics, everything that we base our existence on, would be null and void, would be in danger of being damaged at any time by time travel. So, science fiction movies, stories, and so forth, where you go back in time, change something in the past, and then you come back to the future, and it turns out that history has been altered. That's a violation of causality.
There is a probability that there are other universes. There is a probability that perhaps we'll be able to bend the fabric and rip it of space and time. However, my own past is fixed. I'm not going to be able to change the deaths, the tragedies, the tears that have been shed in my universe. Traveling to the future is easy. Our astronauts do it all the time. Traveling to the past, now that's a problem.